Here we have AP calculus AP problem. Okay, so we have to evaluate the given limit. That is limit x approaches negative infinity. 4x square positive x negative 7 over x square into 5x negative 3. Okay, here the limit we have for x is negative infinity. Whenever we have negative infinity as a limit for x, we have to be very careful with the sign that we are going to get as a result. So for that, first we have to decide the sign of the numerator over here. So to get the sign of the numerator over here, just have to look at the leading term. Leading term means a term which contains a variable with the largest exponent. In numerator, so this is a term which contains a variable x with the largest exponent too. Okay, so here x approaches negative infinity means x approaches a very large negative value. So when I plug in a very large negative value for this stuff, I mean for x square, what will happen? That is 4 times. When I apply a very large negative value for x over here, so this because of the exponent 2, it will become a very large positive value. When this large positive value is multiplied by positive 4, again it will become a very large positive value. So because why I consider the term which contains a variable with the largest exponent? Because this term will dominate the values of the rest of the terms in the expression. So when I plug in a negative infinity for x, that is a very large negative value for x over here, since it is squared, it will become a very large positive value. When it is multiplied by positive 4, again it will become a very large positive value. So for the complete expression, we get positive sign. Okay, now let's decide the sign for the denominator. So for that one also the same thing. We have to consider the term which contains a variable with the large exponent, that is x square, because the value of this term will dominate the terms in the rest of the expression. Okay, when I plug in a very large negative value, that is negative infinity for x over here, so because of the even exponent, so whenever we square a negative value, it will become positive. So when I plug in a very large negative value for x over here, so then when I evaluate x square, it will become a very large positive value. Anyways, the sign of the denominator is also positive. So when I plug in this negative infinity, I mean when I plug in a very large negative value for x, so that the sign of the numerator is positive, the sign of the denominator is also positive. So no change in the sign. So now what we can do is, let me write the limit first. Limit extends to negative infinity. So and also in case, for example, instead of 2, if I have 3, what will happen? So when I plug in large negative value for x over here, because of the odd exponent, it will become a very large negative value. When I multiply large negative value by this positive 4, it will become again it will become a very large negative value. So the sign of the numerator will become negative. But here, since we don't have odd exponent, we have even exponent over here in the leading term. So we get a positive sign for numerator and positive sign for denominator as well. Okay, now so now in my next step, what I have to do is like I have to factor x out with the largest exponent. In numerator, what is the variable? What is the largest exponent of the variable? That is 2. So we have to factor x square out from this expression in numerator. So now let me factor x square out. When x square is factored, what do we get inside the parenthesis? So now to get the stuff inside the parenthesis, we have to divide each term of the numerator by the one I factored, that is x square. Now let me do it. So 4x square over x square, positive x over x square, negative 7 over x square. Okay, divided by, now the same thing. So you have to, in denominator, we have to factor the variable out with the largest exponent. So that is x square. So we can factor x square out. So to get the stuff inside the parenthesis, we have to divide each term by the one I factored, that is x square over x square, negative 5x over x square, negative 3 over x square. So here this x square and x square will cancel out, and limit extends to negative infinity. And so here when this x square and x square will cancel, I'm just getting 4 over here. Let me do it. Okay, here when I divide x by x square, I'm just getting 1 over x. And we cannot do any more simplification in this one. We have to keep this one as it is. That is negative 7 over x square. Okay, here this x square and x square will cancel. We just get 1 negative. So when I divide, when I simplify this x over x square, it will just become x. And there is 5 multiplied over here. Then we get negative 5 over x, negative 3 over x square. Okay, that's all the simplification we can do. Now we can plug in the given limit for x, that is negative infinity. So when I do so, like 4 positive 1 over negative infinity, negative 7 over. So what will happen if I plug in negative infinity for this x over here? Actually, this x is having even exponent. Even when I plug in a negative value for x over here, so because of the even exponent, the complete stuff x will become positive. When I plug in negative infinity for x, that's a large negative value for x. Because of even exponent, it will become a very large positive value, that is positive infinity. Over 1 negative 5 over negative infinity, negative 3 over the same reason when I plug in negative infinity for x. So the value of x will be positive infinity. Okay, now we get 4 positive. Whenever I divide a finite value by a very large positive value or by a very large negative value, that is by positive infinity or negative infinity, so its value will become 0. So 1 over negative infinity is 0, negative. So again, the same thing. Finite value is divided by a very large positive value, it will also become 0. 1 negative. Here 5 is divided by a very large negative value, it will become 0. So the same reason for 3 over negative, 3 over infinity. So 0. So we get to 4 in numerator, 1 in denominator. So 4 over 1 is just 4. So the evaluation of the given limit is 4.